So now I want to go over another parameterization problem that you could see. So what if, let's say you're only given not a point that a line goes through and the direction that the line follows, but let's say you're given only that a line passes through a point P, A1, B1, C1, and Q, which equals A2, B2, and C2. Okay, so what we have is something that looks like X, Y, Z here. Okay, so we have some like P, let's say, and some Q over here. All right, so here's P, here's Q, and some line passes through those. Okay, and we want to parameterize this line. But the thing is, how do we even know like how to name this line if we don't, right now, we don't know anything about the origin or anything, right? Because we don't have a direction that we're going. There's no v vector to work off of. We do have plenty of points. We have 2 points to go off of that they pass through, but we do need this v. Remember from before, our general equation was t times v arrow plus o times p naught. Okay, so we definitely do have some point that we can transfer the line to, such as P, okay? But we do need this vector V, okay? So we could create a vector V, all right, using what we do know, all right? So let's say we want to make this vector V, and we want to make it so it lies on the line, right? So we can actually make it by going from P to Q. So let's say that V equals P to Q. Okay, that would definitely work because it's definitely on the line. It follows the line because it starts at P, goes to Q, and it points in the same direction as the line. So to find that, we would have to do, let's see, this is the same thing as saying that this little arrow down here that I'm circling is called O, and that just stands for origin, O to P, right? It just starts at O and points at P. And then this vector here, the one that I'm drawing now, it goes from O and points to Q, so that's called OQ. All right. So the vector V is actually, according to vector addition and subtraction even, that is equal to, it's going to be equal to the following, OQ. So let's say you go from OQ, so we start down here, and we're going to Q, all right, and then it's minus OP. We're going to flip OP around and add it to OQ. So then we get this vector here, which is the same as V. So we're going to subtract OP. All right. So this gives us, this is the same as vector V. Okay. So basically the way we can rewrite our original vector parameterization, now using the points P and Q that we do know and are given, we can write T times OQ minus OP. All right, and then we have our plus OP there, or you can even write an OQ there, either one. But anyways, okay, so now if we play around with this a little bit, we can say that this is T times OQ minus T times OP plus OP, and we can factor out the OP here, so then we just get T times OQ plus 1 minus T times OP. Okay, so this is, again, this is another parameterization, vector parameterization of a line. So I'll say this is a vector parameterization of line. And this is particularly when you're given 2 points it goes through. It goes, and I'll abbreviate, through. Okay, so this is an important one here. And one other thing I'd like to say about this is that there are a lot of different ways to represent the same thing, if you haven't noticed by now. Lots of different parameterizations, because after all, parameterizations are just ways of naming things. Parameterization, that's quite a word. So parameterizations are just ways to name, ways of naming, okay? And there are a lot of things you can be named, like one person could have 10 nicknames, 12 nicknames, which would be pretty impressive, by the way. But anyways, so there are lots of parameterizations, lots of parametric equations. For example, so here I'll just write them out. So parametric equations for the second thing I showed you. So for I'll call it the points method. This is the one where you're given that a line goes through 2 points, so it goes through P and Q, right? I don't know why I do that comma there. So the parametric equations would be x equals a1 plus a2 minus a1 t, okay? And then y equals b1 plus, and they're all going to have the same structure, same pattern here. And then the last one is just your z coordinate is given by c1 equals, and that was from OP, okay? And then we had OQ minus OP, so this is going to be C1 and T, okay? So it's kind of like, more or less, this part comes from having to subtract one point from the other to get your V vector, okay? But anyways, so yeah, that's pretty much it. And the last thing I do want to note is that for the last thing, the last kind of parameterization, the points one, when you're given that it goes through 2 points. So this was our final vector parameterization, T times OQ. So what this looks like is that you have OP here, okay, so this is like OP, and then we have an OQ, alright, so here's OQ, and then we have a line that goes through where they touch at, hold on, let me try to get that here, pretend that goes through, please. So we have this line, and this is our R of T, okay? And when T, so we have different cases, all right? So first of all, when T is between 0 and 1, that basically means that you're getting this segment here. So from the tip of OP to the tip of OQ, you're getting this line segment. That's what this parameterizes, okay? So this gives you the PQ segment, all right? So it just goes from here to there. That's when T is from equals 0 to T equals 1, all right? And anything in between there, okay? Because when like T equals 0, for example, if T equals 0, then you have 0 here, and you get none of OQ at all, and you get all of OP. And so this is where T equals 0, so that would be this point there. And when T equals 1, if T equals 1, then you get all of OQ, so you get all of OQ, so it goes here, and 0 of OP, because then this would be 1 minus 1, right? So this would be when T equals 1. And then anything in between, if T equals like 1/4 or something, you're going to get something that's like 1/4 of the way there. So you're going to get everything, hit everything in between, okay? Number 2, the second case, could be when T is less than 0, or when T is greater than 1. Okay, then you're going to trace the rest of the line, basically. The points will fall outside this little segment. And the last thing I want to note is there's a special case when T equals 1/2, because that gives you, then R of T is your midpoint, midpoint of PQ segment, okay? So this would more or less, I think halfway would be about here, so that would be your when T equals 1/2. Okay, so that's it for this video. Again, I hope that helped, and good luck on your homework.